In computer science, data is stored and manipulated in what we call data structures. And there are different kinds, depending on how much data we want to hold, the type of items we're storing, and how fast we want to access or update our data. One of the most widely used data structures is a stack. It's not very different from what you imagine of a stack of plates or a stack of pancakes. But this idea, or this data structure, is so simple, yet so powerful, is at the core of a lot of computer science concepts and problem-solving techniques. First, let's formally define a stack. In computer science, a stack is a collection of elements with two operations: push, which adds an element to the end or top of the collection, and pop, which removes the most recently added element. Again, these two look like very simple operations, but with just those two, we can solve a wide range of problems in computer science. Let's take a look at a simple one. Suppose we give our computer a complicated math expression like this one, and we want to just verify that the parentheses of this expression are matching. So let's just extract the parentheses here. We can use the stack to verify this like so. Every time we see an open parenthesis or bracket, we push that into our stack. If we get a closing bracket, we pop the corresponding opening bracket out of the stack. If at the end our stack is empty, then we know our expression is valid. Let's feed our stack an invalid expression to see what happens. Again, every time we see an opening parenthesis or bracket, we push it into the stack. But once we see a closing bracket, we want to have the opposing opening bracket on top of the stack so we can pop it. In this case, we don't, so this expression is not valid. I encourage you to try this with more complex expressions and even add more opening and closing symbols. Let's move on to a slightly more complicated application of the stack. This has to do with functions in computer science. A function is basically a part of our program that may take some inputs, do some computation, and return an output. So things like add, adding two numbers, drawing a circle, giving the position, spawning an enemy in the game are all functions. So a program therefore consists of a lot of these functions. And some functions also call other functions while they're executing. So as you can imagine, this can get very messy, and it would be very hard to keep track of the computations happening, what comes before what, etc. So how does a computer solve this? Well, you guessed it, using a stack. So let's fabricate an example here to illustrate. Suppose we have a function called sit on the iron throne. As we all know, there are many steps required for this function to finish executing, 8 seasons to be exact. But we'll simplify that and say that for the sit on the iron throne function to execute, we need these following functions to execute first: conquer the north, kill the Lannisters, and kill the Targaryens. This just got very gloomy, but bear with me. Now for the kill the Lannisters to finish executing, it needs to call kill Tywin and kill Cersei. The way a computer is going to organize all this is, when the main function, sit on the iron throne, is called, it's going to push all the data associated with that function into the stack. So let's use a logo to simplify that and mark the logo as yellow to indicate that the computer is currently handling that function. Now because our original function needs to call conquer the north, we're going to push that function into the stack as well. And because that function is on top of our original function, we'll have to finish this function first before we can resume executing our original function. So let's say we do whatever needs to be done to conquer the north. So we can take that out of the stack once we're done, mark it as a yellow just to indicate that we're finished, and now we can go back to executing our main function. But our main function then calls the kill the Lannisters function, so we put that into the stack as well. Now the kill the Lannisters function itself calls the kill Tywin function, so we have to put that into the stack, execute it, then pop it off, and then do the same thing for the kill Cersei function. Put it into the stack, execute, then pop it off. So after doing those two, we're done executing the kill the Lannisters function, so we can pop it and move on to the kill the Targaryens function. Finally, once all of those functions finish executing, we can mark our original function as done and then pop it off the stack. And now that our stack is empty, we're done executing our code. That's it. Hopefully you've seen how a concept so simple can be so useful in computer science. There are literally thousands of applications of stacks, and there are other data structures as well fit for different types of problems, and I encourage you to seek them out and let me know in the comments if you want a visual explanation of them. Thanks for watching, until next time.